Hello and welcome to REGO-FIX TechChat. My name is David McHenry. I am the Engineering and Technical Manager here at REGO-FIX USA. Today, I want to build on a couple other videos that we've already produced in the TechChat format. I want to talk about cracking ER collet chucks, what causes it, and what to look for. So let's go back and talk about ER nut torque first. Then we'll get into cracked holders. Okay, so I went back and I grabbed the two tool holders I used in my video to discuss nut torque values. And I have those here on display, and you might remember the 1/8 inch requires 15 foot-pounds, the 1/4 inch requires 46 foot-pounds, so more than 3 times the amount of value that goes into that. Well, you might also remember the demo we did on one of the other videos showing the high Q nut compared to other nuts on the market. What you could see is the high Q nut provided over 2 times the amount of clamping force than a standard metal nut. So now maybe those nut torque values that we talked about before might become a little more important. That 15 foot-pounds on the 1/8 inch compared to the 46 on the 1/4 make a big difference if you happen to get those wrong, knowing we are putting in over twice as much clamping force into the assembly. So that's why REGO-FIX has nut torque values. It guarantees the maximum clamping force without sacrificing TIR or damaging the assemblies. But what causes the holder to crack? So let's talk about what we generally see happens. And hey, let's face it, this isn't intentional. This is somebody trying to get the job done. So here we have our ER16 1/4 inch tool. And what we generally see is I have this 2.5 inch carbide blank, and this is what the cutting tools come as a standard length. And I need to have, say, 2 inches of projection sticking out of my ER16. So I have a very small portion of the cutting tool shank inside the collet, much less than the recommended 2/3 of the collet bore length or all the way through the collet. So I'm really short on that, but I need that length to cut my part. So generally what happens, the operator would torque this down. But you know and I know, if he's already pulling that up a little bit to get the most length he can out of it, he knows he isn't holding on to very much tool shank. So what do? Hey, that 46 foot-pounds might become 60. They put the 46 in and they give it a little extra. That little extra is what causes the collet cavity to actually deform and break. So now I'm holding on to too little tool shank and I'm over tightening it. Well, what happens inside? So inside, my collet actually folds under the carbide cutting tool because the carbide cutting tool is much harder than the collet. The tool holder itself is harder than the collet, so the collet folds underneath. Well, when it does, it becomes a lever and it tries to expand the front. When it expands the front, it actually applies too much stress to the thinnest part of the tool holder, which is the rim of the collet cavity. That force of opening actually causes the stress on the rim of the collet cavity to fracture or crack. That's what causes the most cracks that we see that are out there. It isn't that it's intentional. It's somebody trying to get the job done. They're pulling the tool out as far as they can, trying to get the length they need. Unfortunately, the high Q nut produces so much more clamping force than other nuts on the market, it becomes a very big issue very quickly. Easy solution on that, if you need that extra length, you need to order the tool holder that's the right length for it. My name is David McHenry. Thank you for watching.